Well, welcome everyone to part two of this session. So we're going to be going over not only the basics of R and a brief introduction to R, but essentially how we can integrate R into our notebooks that we made in the prior section. And just to kind of illustrate, what's the end goal for these notebooks? What I have here in another tab is just kind of like an example notebook that I wrote together. And as you can see, you start looking through this, this is essentially like a full-blown report where we have not only text in via Markdown, we have a table of contents, we have different sections. We're using all of the server capabilities and all of the different libraries and ecosystem of the server to generate a report. And you don't need any of this to generate this. All you need is essentially an internet connection. And so what we're doing is we're doing an analysis, we're reporting, we're reproducing our analyses, we're generating results. And then, scroll down, we can also generate images as well. Right here, we're just doing some kinship analyses, and then we're generating some output from that. And then we're integrating that into like an association output, generating some additional tables, generating some output from like a linear model, and then running some association analyses in R tassel, and then generating an output. And so essentially what we have right here is basically a full-blown notebook that you don't need any of these resources. You just need an internet connection. All of these pieces of software, all of this is integrated for you. You don't need to worry about this. But before we get to like this end goal, we have to talk a little bit, of the different steps to approach that end goal. And so hopefully by the end of today, we understand a little bit about R, basically what functions are in the R programming language. Also, we're going to be talking a little bit about variables. And then we're going to be reading in some example data that might be relevant to the scope of your research, or at least in the realm of the people attending this workshop. And then also not just reading that data in, but manipulating it, accessing that data, and also analyzing that data. So if you've never heard of R before, here's my 4-point statement of what R is. R, first and foremost, is a programming language that was created by statisticians for statistics. And so what that means is when you load R into a notebook, right out of the box, it already has a very rich ecosystem that we can use for statistical analysis and also generating very rich visualizations of our data. The third point, and probably the most important point, is that R is going to be free and is always going to be free. This is an open source project. You do not need to pay for this. There's no credit card information. So as opposed to something like SAS or Jump or Minitab, this is going to be a free to use piece of software that's going to be readily available to you. And as Bethany has shown, we can take these R commands and then execute these within our notebook, within code cells. And probably the most important thing is immediately get results. And so what do we mean by that? Here I have in this notebook a couple of code cells. So you notice that we're highlighted on code. And I have a couple of R commands, and I'm going to run these. And so you notice that I get immediate output for these. You don't really need to know what these commands are, but you notice that I ran that play button, I immediately get an output. And so in R, we call these commands functions. And so one good way to think about R is that everything that occurs in R is a function. It is a call to a function. And just like in math, and a mathematical function, we have an input. In this case, we're saying hello workshop attendees, and then we're generating an output. In this first one, we're just outputting that to the notebook. And then in the second one, we're actually counting the number of characters within that collection of text. And as you notice, they share some similarities. So there is some syntax or the way that we write this out in a notebook. And so we usually denote functions with a function name, and then we have open and closed parentheses. And then within those parentheses, we have an input. And these inputs can be specified by parameters. And so you notice here we have this x equals. So this is a this name followed by an equals that is a parameter. And our functions can also have multiple parameters, and these are defined by the actual, R language itself. And as we can see, they'll have some more descriptive names than X as we proceed throughout this notebook. So again, remember everything in R is a function call. So the second thing we're going to do is we're going to read in some actual data. And so to read in data, we're going to be using a function. R is capable of reading in a lot of different types of data. For this workshop, we're just going to be focusing on one specific type of data, and this is delimited data. And if you don't know what delimited data is, this is very similar to something like in an Excel or Google spreadsheet. So for example, I have an Excel spreadsheet. I have my columns, I have my rows, I have values within each one of these cells. But now we need a way to translate that out to just plain text, as what I'm kind of like highlighting right here on my mouse. And so to separate these values, we need a specific character. And we call that character a delimiter. And one of the most common delimited types is using a comma. And so basically just taking this output and then generating it into text. And if we want, we can show you some examples during the breakout session of how to produce that. And so to read in this delimited data, and I'll talk a little bit about this in a second, is we use this function called read.delim. And so as that name implies, we're reading in delimited data using a function. That function is going to take two parameters. The first parameter is going to be the path to the file. So what's the actual text that we're going to be reading into R? And then also how those values were separated within the actual text. In this case, was it a comma? Was it something else? So for example, if I was to read that using this read.delim, here I have this file parameter. I have a path to that file, which I'll show. And then I also have a separator. So this would be the delimiter. In this case, it's a comma. So now if I was to take a look at that plain text data in this little tab right here, we notice that we have rows and we have something that kind of looks like columns, and we have our values that are separated by commas. Okay, so if I was to take that, so notice that it has this text form. Now, if I read that using the code cell, I get this output. And so you notice that it starts to look kind of like a spreadsheet where we have headers, we have descriptors of each one of our columns, we have rows, we have values with each one of those cells, and we can highlight over with our mouse and it kind of highlights the row. And so in R, this output that's generated, we call this a data frame. And so you can think of a data frame as kind of like a container for holding different types of data. So you notice that each column is something that's like indicative. If we were to go out to a field and measure traits, right? You're going to be recording different types of data for each one of our observations. So here you have like a sample ID, that would be a word. You have a location of where you measured that data, and then you have actual measurements. In this case, this is just hypothetical maze data. So this is looking at some hypothetical ear diameter and ear height from two different locations within the United States. And so you notice we output that. So we have rows, we have columns, and so we also have dimensions. So this is 20 rows and 4 total columns. So yeah, we have this object, right, or we have this output to our notebook, right? So how do we actually start working with this data frame object? And this is what comes into the next component of our notebook, which is variable assignment. And so you notice that we just kind of outputted stuff to a notebook, but we need a better way of handling this data that we can start to execute in later code cells. So one way to think about this is this analogy of flowing water, right? So remember, everything in R is a function, right? We have input going into our function and we get output, right? And so just like a water faucet, you're not just going to let that run and let the water go out everywhere. You need some type of container or a bucket to hold that data or that metaphorical water, right? And that's where variables come into play. And so in R, when we want to assign variables, we have to use this special operator. And you notice that this is a left angle bracket followed by a hyphen. And so you can think about this as this faucet where we're trying to direct the output into this container or this variable. And so to do that, we can come up with whatever name that we want for a variable, and we assign it using this assignment operator. So what I'm going to do is I'm going to take that function that we talked about in the prior section. I'm going to read that in to this variable that I'm calling my df. Now, this can be whatever you want to call it within reason. I execute that code, and you notice that we do not get an output this time. It's been piped into this object. Now, if I was to take that object and move it to an additional code cell, and I run that, I get my data frame. So now we've basically taken that data frame, put it into a bucket that we can then use for our downstream analysis. But you can assign other things than just data frames. You can assign literally anything in R to a variable. So here I have the number 1, and here I have some text that says hello. I'm going to assign those to X and Y respectively. So you notice that there's no output. But now I call X in another code cell. I run that. I get the number 1. And then I run Y. I get hello. And I can also pass these variables to functions, right? We can assign this to addition. So addition is technically a function in R. We can run that. We get 1 + 1 is 2. And we can use that nchar function that I showed earlier, counting the number of characters. I get 5 elements or 5 letters within that text. So with that being said, we're going to have a little breakout session now to go over what I just showed. Don't worry, in the breakout PDF, everything that I talked about is going to be in there. So again, just to kind of navigate where that is, we go up to our directory here. So we click on the little file browser. We go to shared. We go to workshop, we go to breakout room instructions, and now we're going to go to breakout instruction part 3. So double click on that. You're going to have a series of different parts. There's a lot of different objectives in here. So we have part 1 talking about functions. Part 2 is reading in data and assigning that data to a variable using this location on the server. And then if you finish that, I have a bonus round if you want to tackle some of this. So this is a little bit more involved, a little bit more open-ended. But again, if you finish the part 1 and part 2, go to the bonus round. So with that, should we break into different groups?